Peptide fragmentation in a tandem mass spectrometer is characterized by a set of numbers that we denoted delta is equal to delta 1 up to the delta k. And these deltas, they are corresponding to the type of the ions that are released when the small peptide is converted into the small fragments in the mass spectrophotometer. So these type of delta represents the type of the ions, and it is called the ion types. So a delta ion of an N-terminal partial peptide pi is a modification of pi that has a mass mi minus delta, and that corresponding to the loss of a small chemical group of mass delta, as we have seen previously in the case of a peptide that release the water molecules and the ammonia molecules. So these small chemical groups of mass delta when P was fragmented into pi. The delta ion of C-terminal peptides is defined similarly, and the most frequent N-terminal ions are called the B ions, means the ions B corresponding to the pi with delta is equal to -1. And the most frequent C-terminal ions, they are called the Y ions. It means that the ions Yi corresponding to the pi with the delta value of 19. So as we can see in the figure, these examples of other frequent N-terminal ions are represented by beta H2O, and we can see that this is the values of the Yi, and these are represented Bi. And we can see amino acids, they are present in a peptide, and it can be fragmented as G, one fragment. If we consider 2, GP. If we consider 3, GPF. And if we 4, GPFN. And this is from the N-terminal, and if we consider the C-terminal, then similarly it will be from this direction. The main thing is that when the mass spectrophotometer is used, small chemical ions that are present within the peptides, they are removed, and the mass of those peptides is reduced after the removal of those small chemical compounds.